quest today is to finish off how to find area between two curves. We're going to look at a variety of different kinds of questions. That's actually for there. Let's show you. This is a version of question 8 in the homework. So you might get really lucky and it will be this, but the chances are that'll be 15x or 2x and these will change as well. But at least you'll get the gist of how you do that question. Now, the way I would approach this question is, step one, I need a picture. The reason I need a picture is there might be a crossover, right? So I can't just say start at this number and finish that number and do this guy, take away that guy, right? Because it may not be as simple as that. So step one is to do a picture. If that picture has a crossover, then step two would be find the point of intersection. And then step three would be set up the integral and get the answer. Now for some questions, step 1 and 2 aren't necessary because they give you a picture and you can see all the numbers you're going to use. But this one is, I'm going to pretend that this one is a little bit further back and I'm going to show you how I would tackle that question. So I'm going to do the easy way. I've put a link to a piece of software called Desmos, which you may or may not know about. It's really cool for this section because it allows you to type in just these usual functions, but it's much bigger and clearer. And it will also allow you to do x equals y squared and x equals y plus 1, which is going to come later today. So you need to see what those are like. And those are a real pain to try and draw. You can't draw them with your TI-84. But since my TI-84 is here, I'm going to change this. So it was 5. So I did do the question with my class. It was just a 5. And right. So you type in your two guys, tan 9x, 2 sine 9x, check. I'm going to go to the window. Negative pi divided by 27 is the low value of x. The maximum value is positive pi divided by 27. And now we're going to do zoom to fit. Zoom 0. I like zoom 0. You can pick what you like. And eventually we get a picture that looks something like this. Okay, do you see it's got a crossover? Would you also agree that the crossover is at 0?
Yep.
So I don't really need to focus on step 2. So if I'm drawing a little version of this, it looks something like this. This guy here is the pi over 27. This guy over here is negative pi over 27. This guy here is 0. I'm going to just go back again. Why am I doing that? You have to do it this way. And I'm going to make the tan guy thick. That's just so I can be sure who's the tan and who's the sine. So here goes again. So this is the tan. And this is the sine. So this guy here is the sine of 9x. Actually, it's 2 sine 9x. And this is the tan of 9x. Now I'm going to do step 3 here, but I'm going to do a little bit of a cheat. Well, maybe not a cheat, but would you agree that by symmetry, this banana shape is the same size as that banana shape? So if I wanted to find the entire area, couldn't I just find that piece and double it? And that would be less work. Always think of less work, right? That's kind of rule of the game. So I'm going to do 2 times the integral from 0 to pi over 27. That's good. We're almost in step 3 here, right? This is me creating the integral that we're going to use. Now, sine or tan, who goes first? Who goes second?
Sine goes first, tangent
Because it's
second.
higher up. Agreed? Agreed. That's why I chose that. Right, we've set up the integral, and hopefully, but not in this case, that integral is very easy to do, power rule, whatever it is, and off you go and do it. Unfortunately, this guy is not easy to do. I can do it, but it's not, you know, just a simple, you know, one thing. So I am going to do it separately. Let's find out how to get the integral for that guy. The problem is that's not x. If that was 2 sine x, wouldn't the answer just be negative 2 cosine x and everybody be saying, what's the deal? But it's not, it's 9x.
Quick question.
Yes.
In step 3, why did you set 2 sine 9x minus tangent of 9x?
It's always big, take away small. So when you look at the formula, it looks like that.
Oh, and then that difference is what's inside.
Yeah, exactly.
I.
Okay. Right. This is a U sub question. Tell me the U sub.
9x?
Yeah. I guess this would qualify under sine of ugly guy is your U sub, right? You know, my kind of generic way how to find U subs. So differentiating U with respect to x gets me 9. Crossover, and then isolate the dx. So this becomes 2, the sine of u, 1/9 du, which becomes 2/9 the sine of u du. So far, so good? Right, now, according to antiderivatives, isn't the antiderivative of sine u negative cosine u? So this fella is negative 2/9 cosine of u, which we will call negative 2/9 the sine of 9x. So I'll go back here and I'll write down negative 2/9 the sine of 9x. Okay, that's cool. This one.
I have a question.
Yes.
Why were you able to convert from cosine to sine?
Because I integrated it, the antiderivative. Oh, shooting space.
I was confused about that too.
Okay.
It was a deliberate mistake that only one of you noticed. Oh God, that excuse isn't going to last long, is it? No. Do you know that I used to be conceited, but now I'm perfect?
That's how that works.
I'm telling you, I'm wasted on this class. I am. Okay. This fella here has an issue. The U sub 9x will not help you, because if you use the U sub 9x, all you will end up getting is 1/9 of tan u du. And you'll still be in the same boat as you were. You still don't know the antiderivative. So you got to approach this differently. And trig is always going to be the worst ones, because trig can have so many different ways things can happen. But can anybody remember tan of 9x being written in another form?
Sine of 9x over cosine of 9x.
Now, superficially, you might think you're making your life hard, but you're not. You're actually helping yourself. I can now do a u sub. The u sub is not 9x, but it is something to do with these two guys. Which one is my u sub?
Cosine of 9x?
Correct. A little hesitant, but correct. Isn't there a rule, if it's a fraction, the guy in the bottom is your u sub? Right, so I'm using that rule. And you say, well, what about that 9x? Don't worry about it. It's suddenly going to become, in a line or two from now, oh, ain't a problem anymore, right? So don't worry about the 9x. It will sort itself out. But we have to be really careful about the math. So I'm pausing while I do this. If you differentiate the cosine of 9x, differentiate, don't you get negative the sine of 9x? Do you get anything else?
You
Don't
get
you also
9.
have to use the chain rule?
Yeah, so that means you get 9. So negative 9 sine nx. Does that make sense where that 9 came from? Now you do the crossover next. And then you isolate the dx. Have you noticed that the way I do u subs is the same way every blinking time? Now, some of you after a while may adapt this, and I've seen people who take that line and use it, and that's fine if you want to do that, and I'm okay with that. I just find it easier if you do everybody the same. It's just a consistency thing with me. So as I'm saying, you may find a little bit of a shortcut sometimes if you do the u sub. It can happen. Now in this case, the sine of 9x is going to stay put just for a little while. The cosine of 9x is u. The dx gets replaced by that guy. Now, isn't something like almost magical has happened? Remember that sine of 9x, which might have been a little bit of a worry to you? It's actually get killed off, didn't it? And so what I'm now looking at is negative 1/9 1 over u du. And I'm being very careful to separate this guy from that. That way, when we come to do its antiderivative, won't it be a lot more clear that it's just negative 1/9 the log of u? If you write it as negative 1 over 9u, some people start having the log of 9u in their answer because they see a 9u in the bottom and they think it's a log in the bottom, so you get a 9. And no, it's negative 1/9 of log u, which turns into negative 1/9 the natural log of the cosine of 9x. Oh, and while we're at it, aren't we going to subtract this answer? Right, subtract it. So can you imagine there's a negative here and there's a negative here? Well, won't that turn into a positive? And that's why this is now plus 1/9 the natural log of the cosine of 9x evaluated at x equals 0 and x equals pi over 27. And at this point, I'm going to do my ... thing. Isn't this just, what's the word? Well, apart from being boring, isn't this just a matter of plug and chug? And quite messy plug and chugs. Aren't you going to have to find the exact value of the cosine of a third pi? Not nothing 0.1234, but its exact value, right? The root 3 over 2, right? And you're going to have to deal with logs of root 3 upon 2 and all sorts of bits and pieces. When you're finished, your answer should never be that. Never be a decimal. Unless you get the very, very rare question where it says, give the answer to 2 decimal places. All your answers are going to look really ugly. This one especially. This is not the right answer, but this is how ugly it might end up looking. It might end up looking like 4 root 3 over 3 plus 5 halves, the log of 3, take away 1/2, the log of 7, right? It's going to be ugly with bits to it. And that's okay. It's all right. You just have to accept that not all answers are a half, right? Some of these answers are just going to be, oh, that doesn't look right. Trust the math. If you did it right, ugly answers, ham. They just do. Right, that was quite a long question. Are we comfortable with the process? Are we good? Right, let's move on to another issue. Suppose I wanted to do that guy. I know a start and a finish. That's good news. Don't I basically need to see, do these cross over, right? So I'm going into stage 1 again, phase 1. And phase 1, we go y equals, clear these 2 guys out. You could do everything I'm doing right now in Desmos, but I'm keeping Desmos to the x equals y cubed question so I can use it then. So in this top one, I'm going to do, I've got to go up there first. I'm going to go 3 times the cosine of 4x. And while I'm at it, I'm going to make that the dark thick one. And then we're going to do 3 subtract 3 times the cosine of 4x. I'm going to go to the window, and it's going to be from 0 to pi divided by 4. So when I do zoom 0, this is the picture. Would you agree there's a crossover? Right there. You see it? Crossover. So here's my basic version of this. It doesn't need to be too accurate. There's pi upon 4. This curve here, which is the dark one, is 3 cosine of 4x. And then the other one kind of starts here, crosses over somewhere like that, and then it levels off up here. And this one is going to be y equals 3 take away 3 cosine of 4x. Now I have a finish and I have a start. So that's basically what I'm calling step 1, right? Draw the damn thing.
You'd have to basically integrate this twice, right? Because they're not
they're
you
not
can't just
equal.
multiply. Yeah, you can't just multiply it by 2.
You can't. You're hoping that's the same size as that, in which case you only find one of them and double it. And there's a fair number of questions where that's true. But even in my bad drawing, and certainly the calculator proves it, would you agree that the bit in the left is not the same area as the bit in the right? So you are stuck
Definitely.
with 2 areas. You're quite right. Also, don't we need to find that intersection point so we know 0 up to this guy is one area and then this guy to the end is the second one?
Yeah, that's my
Which is
question,
where,
how we find that.
well, let's find out. Step 2. If you want to find where 2 curves intersect, you take the equation of the first curve and you set it equal to the equation of the second curve and you solve. Now, you're hoping that you got a quadratic to solve or something that's easy that you can do from, you know, your Math 99 days. But this is a trig equation, so this is going to have to be done using 142, right? Your trig class. Let's use my tried and tested method with the made up name, because I made up the name, called as long as you do it to both sides, it's okay rule, So tell me what to do to both sides that's going to get this closer to being solved.
Divided by 3.
Oh, you could, and there's nothing wrong with doing that, but can we hold that one and do something else first?
Add cosine to both sides.
So now you've got 6 of these equaling 3. Right, what are you going to do to both sides now?
Now I would divide by 3.
Yeah.
Well, do you want 3 or 6? You have a choice.
Oh, you should could do 6.
Yeah, make the other side 1/2, yeah.
I would do that because that gives you a cosine that you recognize.
Right. Now, if you go to your unit circle, which is what you were looking at, I think, what angle, forget about the fact it's cosine 4x right now, what angle has a cosine of 1/2 in radians?
Pi over 3.
Okay? Which means that 4x then is pi over 3. That angle there is not pi upon 3. 4x is that. So won't x be pi over 12? We have found a magic boundary point. So when you were saying I'd be curious to see how to do it, do you see how you had to do it? Now, you cannot do that on the calculator because the calculator will just tell you it's 0.123. It will not give you the exact value. And we need exact values because that's the name of the game here, right? Exact answers, not decimal approximation answers. But at least now I'm ready to set this up. And I guess we can give them names. I'm going to call this piece A and this piece B, right? So essentially, if I want to get the total area, I won't have to find A and B separately and add them up, right? So the area is just going to be A plus B. Let's set up the integral for A. Now it goes from x equals 0 to the newly found pi over 12. Now we need somebody take away somebody, don't we? In area A, who do you write down first?
Three cosine 4x.
Agreed. Take away the other guy. And I'm going to have to stick an A there because it took up so much room. I am not going to do the integral to that guy yet. 3 take away 3, take away a takeaway is an add, so it's now 6 cosine of 4x, take away 3. I can't emphasize enough why you need brackets around this. You see, if you didn't put a bracket around that, you might accidentally cancel the 3 cosines and think you're only integrating 3. Because it is subtract both. So, can I just say dot, 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 and eventually you get the answer? Oh, a minor issue, but we've seen it. How am I going to get the cosine of 4x? What method am I going to use?
Substitution rule.
And who's the u sub going to be?
4x.
Agreed. 4x. Just like the earlier one. You see how something that you've learned in a previous question can help you in a slightly different looking but quite similar question later on. So if you want to do this one, a little note to self, use u equals 4x and dot, dot, dot. Right, let's look at B then. And B is going to start at pi upon 12 and finish at pi upon 4. Only the red guy is going to be first. And you're going to take away the black guy. And so that's going to simplify a little bit by collecting like terms. And it's going to be 3 take away 6 cosine of 4x dx. And dot, 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 dot. Now, you can save yourself a little bit of work here. Aren't you going to have to find the antiderivative of 6 cosine 4x? Right? You're going to have to do that. Once you've done this question, can't you use that answer to help you do this one without having to do it from scratch again? I mean, if you've already found out what 6 cosine 4x is, isn't it not that difficult to figure out what negative 6 cosine 4x is? And that should, you know, maybe save you a couple of minutes, but it's better than nothing, right? And we are done. So I think the lessons we're learning right now is trig is awkward. Solving trig equations is not as clear as, you know, when does x cubed equal 2x, you know, something that's relatively easy to solve. Trig can be much nastier. And we have to be aware that in trig questions, you sometimes need to know identities and exact values. So a lot to take in. So I hope when you were doing 142 that you didn't lock it up in a little room and turn a little key and throw it away, and now you can't get in to find out what you learned, right? So hopefully it'll come back to you. So we are now going to look at the final kind of area between two curves. What's different? Well, the curves we're going to do aren't going to be y equals x cubes or y equals sine x's. They're going to be x equals y cubed and x equals sine of y. Now, when you do curves with those kind of equations, do you notice that they are kind of vertical curves? If I turn them on their side at 90 degrees, you see that you basically turn a 90-degree thing. And we are going to find the area that's shaded between the red and the green. And the formula, pretty much the same. It's from y equals c, whatever that number is, to y equals d, whatever that number is. It's going to be one function take away another. So the problem was when it was, you know, the x's, wasn't it high guy first, take away low down guy second? That was the rule, right? High guy first, low guy second. When you do these guys, right hand side guy first, left hand guy second. Okay, so apart from that, the algebra is going to be identical. So once you finally get this thing set up, you're just going to integrate in the usual way. The only difference is you're going to integrate y squared with respect to y. Well, you know how you do t squared, isn't it a third t cubed? You know how you do x squared, isn't it a third x squared? Well, if you want to do y squared, it's just a third y cubed, right? It's the same thing each time. So where's my first guy? Here's my first guy. We're being asked to find the area between this curve and this curve. So I'm going to do step one, to which most of you, including me, I'm sure when I first got to do that, would be saying, I don't know how to sketch those guys. And my TI-84 calculator won't know how to do it either. That is why we need to go and we need to find a piece of software called Desmos. So if you can, come on, where are you? Here we go. Right. I'm just getting into Desmos, so if you can kind of bear with me for a few seconds. I've put a link to Desmos on Canvas. So we're doing the graphing calculator thing. It'll take you straight to it. Now I'm going to have to go out and in and show you what I just have. So, darn it, in space, where are you hiding? Here we go. Are you all looking at a picture that says Desmos at the top? Great. So, the first curve was called x equals y squared minus 2y. So I'm going to go in here, click, I'm going to type x equals y, you know, the caret symbol, squared, take away 2y. And that's what it looks like. a big red ellipse on its side, and I'll hit enter. And the next one's going to be x equals y take away y. I didn't put the equals there, did I? Thought I had. Equals, it's better. Y take away y squared. Now, it's really cool, Desmos. I like the fact that they color code things, so you know which one's which, right? You see the red one's this guy here, and the blue one's next to it. Now, in my mouse, I'm zooming in here. Can you see a pretty detailed picture of what those curves look like now? So I'm doing a very basic sketch of what's on this screen so that when I return, you can say, oh yeah, I remember seeing something like that. And black guy is it's going to look a little bit of a mess because I made an oopsie, but I fixed it. Okay, so let's show you what we've got to work with then. So do you see that Desmos is going to be your friend for sketching? Now you can actually use Desmos for all the questions, including the y equals sine 5x stuff, right? But if you're going to do that, you're going to have to go to the top right-hand side and adjust the x values to negative pi upon 4 and plus pi upon 4 and things like that. So back to this one. Okay, would you agree that it is just one area? It's not got any crossovers. So that's good.
Right.
Agreed? Now, I need to set up what the integral looks like. I'm pretty sure I know this guy is 0 because it's the origin. And so it's from y equals 0. What I don't know yet is this y coordinate here, right? Because that's going to be whatever goes there, right? Now, on Desmos, I could read off the answer. It was actually 0.5, and I'm 99.9% sure it is 0.5, which, by the way, we will call a half because we don't like decimals, right? But not all the time is that crossover, right? That intercept going to be a nice number. Can you imagine that in some situations it might be the square root of 2?
I think Desmos shows that as being 1.5, not 1/2.
Oh, 1.5?
I'm getting negative 0.75.
We can't
That's
be
what I'm
getting, it's the y value we're talking about.
Oh, yeah, that's 1.5. My bad.
Is it 1/2 or 3/2, Kathy?
3/2.
Okay, I'm now about to show you how you would do that as a verification and also how you would do it if the answer was square root of 2. If you want to find out where two things intersect, don't you solve one equal to the other? Agreed? And you know what method I'm going to use? As long as you do it to both sides, it's okay, rule. So let's start doing stuff to both sides. Tell me something to do.
Divide both sides by y.
No. And I'm kind of forcefully no. Normally I should be nice when people do that, but I want to make it so you won't do it again. If you divide both sides by y, you will simplify the question. That is quite correct. You will also destroy one of the solutions, which in this case won't matter because it's 0. But in the future it might matter and you'll not know that there's a 0 possibility.
Well, you could add y squared to both sides and then add 2y to both sides.
Well, let's do it a slightly different way. I'm going to add y squared to both sides and I'm going to subtract y from both sides. I'm going to try and control your urge to divide both sides by y. Now, if you subtract not subtract. If you, God, you got me. If you pull out y as a common factor, do you now get the two solutions? First one, do you see that matches that guy? What does this one get you? What's value of y makes this factor 0? Because that's one of our two solutions.
2/3.
3/2.
And didn't we already get Desmos to say 1.5? Now, if you did 2/3 and Desmos says 1.5, wouldn't you have a quick look and say, oh yeah, I should have switched the digits. I'm cool. We're good. Right. Now, remember the rule, f of y, take away g of y, who goes first, take away who goes second? In this question we've got here, isn't the black one to the right and that goes first? And is it the red curve to the left and it goes second? Remember the rule for this is right first, left second. So this fella is x take away y squared. X, where'd that come from? Is y take away y squared, subtract y squared take away 2y dy. So this will become the integral from 0 to 3/2. Y take away negative 2y is y add 2y, so you get what, 3y minus 2y squared dy. And can I do my dot thing now? Wouldn't that just be a power rule? Okay, then I can do my dot if you need another line. That's what it would look like.
Could you move up the?
Are we comfortable with the added complication of our equations are now going to be x equals functions of y rather than y equals functions of x's? But apart from that little idiosyncrasy, isn't it very similar process in both methods, both situations? Are we good? Right. Now, what I want to do then is look at the homework questions and see if I've done enough for us to be able to do them. And I might come across one that I'm going to say, oh, we should have done that one. Or an example like that. The first couple of questions are, they make a meal of it. This is question 1 from the homework. There's a little video to watch, which I think are always cool things. And basically, they're taking you through every single step until you get to the final answer, right? In this question here, do you know they've done the double thing? And what they're doing that for is, see this piece that's blue? They're saying it's the same size as the...
We can't see your screen.
Ah. Then thank you for telling me that. That's to screen 2. There. They're saying blue and, I don't know, whatever, yellowy color, orangey color are the same size. So that's what's going on there. Right, can you see in this question, I've got the guy to the right and the guy to the left. And here is their setting out the working. So it's basically, you know the stuff you would write by hand? You're just going to fill in boxes. Some of which are told to you, some are missing, and you fill in the missing ones. Okay, right, let's look at this fella straight off the bat. This one is really good because you don't need step 1, draw a picture. You got one? You don't even need step 2 because don't you know you're going to do from -1 to +1? So aren't you really left with who goes first, take away who goes second? Agreed? So this would be the integral from y equals -1 to +1. Who goes first, red or blue?
It'd be red.
Red first, because it's to the right. Remember, to right first, to the left second. So e to the y, take away all of that. So remember, take away y squared plus y, right? So stick a bracket round the thing if you're the kind of person like me who gets careless. Because a +7 is not going to get you the same answer as a -7, right? So if you don't get the sign right, you're going to get this question again is the x equals function of y version. Would you agree? What are the limits for y here? They're kind of there. Y equals 0, I can tell you. That's this one, right? But what's this guy's y value?
7/2.
7/2. How do we know it? Well, maybe it's not clear, but you see that point? This is its coordinates. And wouldn't the y coordinate be 7/2 mean that this guy is at 7/2? If you look really carefully, isn't there a little mark halfway between here and here? So I'm assuming that's halfway between 3 and 4. Oh, and do you notice it's not 3.5 and it's not 3.5? We are sticklers in math. Fractions should be top heavy, right? Should be improper fractions. This one, won't you just use Desmos or plug it into your calculator? Now they have a guy called x equals 6. So let me leave that for a second and show you what that has got to do with the price of cheese. Can you imagine you did one of your integrals and it looked like this, and you did the other integral and it looked like that? The x equals 6 is telling you to stop here. Won't you have to find that guy so you know the start number? Now, let me return back to the question and we'll talk about what is that start value going to be? Well, it's the crossover point. And if you want to find out where this guy is equal to this guy, which is that guy there, if you were a betting man, would you probably guess, if you're a betting person, would you guess x equals 1?
Yep.
If you weren't sure, wouldn't you make 2 equals x equal 2 over x squared and solve the equation by cross multiplying? And you would get x equals 1. If you're wondering what this little vertical rectangle for, it's more of a distraction to me than anything else, but isn't it basically to help you with the top guy and bottom guy? So you're going to have to figure out which one of those two curves, the one that my mouse pointer is going on, hopefully you can see my mouse pointer, and which one the other one is. Now if you plug that into your calculator, won't you make one of them thick and one of them skinny? If you're doing it in Desmos, won't one of them be blue and one of them be red, so you'll be able to figure out who's who? If you, by mistake, switched places, how would you know that you did it the wrong way around?
You'd end up with a negative area.
Right. And the cool thing about that error is it's very easy to fix. Suppose you did it the wrong way around. Everything else was correct. You just integrated the wrong way around and you got -8. Wouldn't the correct answer just be +8?
Yep.
So I'm not suggesting that you keep making mistakes. I'm just saying it's an easy mistake in WebAssign homework to fix, right? In a test, I much prefer you to not just make it positive, but to do it right the first time, okay? So there's a left to righter. You agree that's pretty straightforward now? A left to right again. Oh, there's 4 pictures. Well, basically, don't you look at Desmos and I don't know which one it is because it's hard to tell. If it's that one, that's one you pick, right? Okay. If I was wanting to find the 2 y values, right? This one here and this one here, right? So I had to know where to start and finish. Couldn't I set 6y squared equal to that one and just solve? And I think, but don't quote me in this, I think almost all the answers are nice numbers that you could probably use Desmos and just look at the y value and it would be clear what it would be. But you know, there's always going to be one square root of 2, isn't there, in the world? So you can't do that in every case. So think about the algebra way of doing it. Hey, do you recognize this one as one we did at the start of today? At least like it. Actually, didn't we do one just like this as well at the start of today? This one, pretty easy to do. When you do Desmos, don't quote me on this because I can't quite remember, but I believe it's this one here. But if it was this one here, can you see it's -1/2 to +1/2? And it's an up down. Can you see it's a y equals x and y equals x kind of story? Oh, the absolute value is not a big deal. I'll let you figure that out. And our last question is good. Is a practical use for areas under curves. Now, the first question is, which car is ahead after 5 minutes? Well, you could say 5. I'm going to say 4. It's the same idea. Do you look at car A and then blue is car B, and this is their velocity against time? At the 4-second mark, by the way, it's the same answer for the 5-second mark, but at the 4-second mark, A or B, who's further ahead? A
They're the
or B?
same.
I agree. Why?
Because the area under A is greater than the area under B, and the area under the curve represents the displacement.
Yep, and you're done. Which is why you pick that dot. And what is the meaning? Right? Now, which car is ahead after 10 minutes? That's going to be a challenge. 1, 2, 3. I do not know what this A2A is. In fact, ignore it because I don't even know why it's there. But
Because
1,
they can change
2.
the value of A for each student.
Oh,
They have A
so
equals
that'll
5 on
actually be a
each side.
5 or a 10.
Yes.
Oh, so I don't get to see what this is my issue. I don't always get to see what you get to see. I get a more generic version. Okay,
Every time
so
we have a
what
red number, that's the number they can change.
that I've recognized. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Okay, you're going to finish there. If you start at 0 and you finish at 10, and you're being asked who is going to be ahead of who, isn't it a matter of trying to do a guesstimate on the area under the blue curve from 0 to 10 and the area under the red curve from 0 to 10? So I'm going to make a commitment. I think blue, the B, is going to be ahead of A after 10. And the reason I'm going to say that is that this area here, the kind of mauve colored thing, isn't it not as big as this area in the white? And what that'll basically mean is, won't one of them overtake the other? Won't B eventually catch up and then go beyond them? And that comes to the guessing part, and I am totally useless at guessing, so I'm going to guess 6. So I'm saying round about here is when the first one catches up to the second. Now, if it's not, I'm going to pick 7. And if it's not, I'm going to pick 8. But since you get 3 guesses, won't you get it right, one of those 3? So that will be it. It's not a very, but I mean, that's how engineers do things, don't you? You build a bridge, if it falls down, you don't build it the same way. You do something different the second time so it doesn't fall down. Actually, if you're a really good engineer, won't you not build one to fall down the first time? But even today, things go wonky. We have learnt some cool stuff today, didn't we? Right, so hopefully I've given you all the help that you would need to get area under a curve, or area between curves, I should say. So we are good.